Okay, so in this part 2 video, we're going to take a look at multiplying polynomial expressions with each other. And the first property we're going to take a look at is the distributive property. And this is going to help us multiply two polynomial expressions when we're not dealing with a monomial. So let's go ahead and write these expressions. So say I have x plus 5 times the quantity of x plus 2. Keeping in mind in each one of these expressions I have this first term, second term, so two terms. First term, second term, two terms. So I'm multiplying two expressions with each other that both have two terms. And this makes it nice and easy to use the distributive property. What we want to do is break up this first expression, the x plus 5. And I could do that by rearranging it, taking the first term, x, and multiplying it to the second expression, x plus 2. And I'm going to separate this first operation with an addition sign because of this addition sign right here. If it was a minus sign, I would put a minus sign right there. So now I'm going to take the second term, 5, and I'm going to multiply it by the same second expression, x plus 2. Noticing that this expression doesn't change. It's the same because the first term of this expression is multiplying the second expression, and the second term is also multiplying the second expression. From there, I will distribute. This is where that term comes into play. Oops, I'm spelling it wrong. Distribute. There we go. Meaning I'm going to multiply the x to the first term and the x to the second term. I'm going to multiply the 5 to the first term and the 5 to the second term. So I know that x times x is x squared. I know that x times 2 becomes 2x. Oops. I bring down the addition sign. I know 5 times x is 5x, and 5 times 2 is 10. From here, I just want to simplify. Looks like the only like terms I can combine is the 2x and the 5x. So I'm going to bring down the x squared, and I know 2x plus 5x is just 7x because we add the coefficients. 2 plus 5 is 7. And nothing happens with the 10, and that would be our final solution. Okay, let's take a look at another example. This time I will color code it, maybe a little bit better for you to understand the distributive property. So say I have an expression of x squared plus 2, and I'm going to multiply it to this expression x minus 1. Okay, so again, I want to take that first expression, the x squared plus 2, and I want to multiply it to this second expression. So I'm going to take the first term of this first expression, which is x squared, okay, and I'm going to multiply it to that second expression, x minus 1. I'm going to put an addition sign because there's an addition sign in that first expression. That second term is 2, and I'm going to multiply it again to that second expression, x minus 1. From here, I'm going to distribute. I'm going to multiply the x squared to the x and the x squared to the 1. Bringing that down, I get x squared times x becomes x to the third, because the exponent of 2 plus the exponent of 1 becomes 3. X squared times minus 1, which I can think of as negative 1, becomes minus x squared. Okay, now I'm going to do the second operation, the 2 times the x, and then 2 times negative 1. I bring down the addition sign right here in the middle. 2 times x becomes 2x. And 2 times negative 1 becomes negative 2. I want to try to combine like terms, but I see that there aren't any like terms because, no, I'm not going to buy more storage, so leave me alone. Okay, so I can't combine any like terms. I have x cubed, x squared, 2x, -2, and this is actually in standard form, so I can just leave it like this. This would be in its most simplified form. Okay, let's take a look at solving polynomial expressions when they're multiplying using the FOIL method. And what that stands for, it's an acronym for first term, outer terms, inner terms, and last terms. So let's just take a look at an example, and I'll show you what that means in detail. So we have an expression x plus 3 times x plus 2. And I'm going to use the FOIL method. And the FOIL method is a form of the distributive property, but it's kind of how we organize our multiplication so that we kind of end up in this kind of standard form at the end. So with the FOIL method, I am going to just rewrite this expression, x plus 3, x plus 2. Okay, and I want to first multiply the first terms in the series. So that would be the x's. So the first terms in the series, when I multiply them, I get x squared. Let me do this one with a different color ink. I'm just going to rewrite the expression over and over again to fill in the acronym. So I have x plus 3 times the quantity of x plus 2. The next comes O for the outer terms. And that's going to be the terms on the outermost placement of this expression, which would be that x and that 2. X times 2 becomes 2x. Okay, now I'm going to rewrite it again and do the same thing. Quantity of x plus 3 times the quantity of x plus 2. I come to I, and that refers to my inner terms I want to multiply. Those inner terms would be the 3 and the x there. 3 times x becomes 3x. And the last one would be last, actually. So x plus 3 times the quantity of x plus 2. And that acronym L is for last, meaning I want to multiply these last terms in the expressions, which is 3 times 2, and I get 6. So as you can see, that acronym FOIL for FOIL is your first terms, your outer terms, inner terms, and last terms. Okay, and then from there, we can just rewrite it down below. So I have x squared plus 2x plus 3x plus 6. And class, don't worry, you won't be doing this every time when you do it. I'm just creating this kind of organization to show you the order process and when you use the FOIL method. Okay, so now down here, I'm going to combine like terms. I'm going to combine the 2x with the 3x. That becomes 5x. So let me rewrite this as x squared plus 5x plus 6. And that would be our simplified solution. Okay, why don't we take a look at one more example before we move on. So let's say I want to multiply x minus 2 times the quantity of, say, x squared plus 6. And I want to use the FOIL method. When I use the FOIL method, I want to do first terms, which becomes x times x squared. I get x cubed. Then I want to do my outer terms. Let me put plus here, which becomes x times 6, and I get 6x. Then I want to do my inner terms, which is the -2 times the x squared. -2 times x squared is just -2x squared. And my last terms, which is negative 2 times positive 6, which I get negative 12. I look at it, I can't combine any like terms, but I can put it in standard order by moving the negative 2x squared in front of the 6x, the positive 6x. So I'm just going to do that because I want it in standard form. So I get x cubed minus 2x squared plus 6x minus 12, and that would be our solution. Okay, this is the last example we're going to go over, and notice we are not just multiplying two binomials, but we're multiplying a binomial with a trinomial. Unfortunately, with this one, we cannot use FOIL, because if we use FOIL here, it skips some terms. It ends up skipping this term, because if we go the first term, okay, first term to first term, then we go outer terms, okay, we go outer term and outer term, then we go inner term, and then we go last term, and it skips this. So we can't use FOIL, but we can kind of use a variation of the FOIL and the distributive property to solve this expression. So what I'm going to do here is I'm just going to show you by drawing the arrows in this order. So I want to take this first term in this expression and I want to multiply it to each term in that second expression. So all I'm doing is just drawing the arrows now, and then I'll write it out later. Then I want to take the second term, which is the 2, and I want to multiply it to each term in that second expression, making sure that each term actually does multiply with each other, that they get paired up. So if I were to rewrite this, that would look a little something like, okay, say I have my x from that first expression, and I'm going to multiply it to each term of that second expression. And then I'm going to take the positive 2 and multiply it by each term in that second expression. Noticing that this looks like how we would use the distributive property, but also kind of using that FOIL approach by drawing the arrows to making sure that each term multiplies with each other. Okay, so let's go ahead and solve this. So I have x, let me use a different color actually, let's go with blue. I have x times x squared, that becomes x cubed. I have x times negative 5x, that becomes negative 5x squared. And then I have x times, x, whoa, where did those go? My arrows disappeared. X times 4, that becomes positive 4x. Let's do the same thing with this second operation. I have 2 times x squared, that becomes 2x squared. I have 2 times negative 5x, that becomes negative 10x, because it's 2 times negative 5, that's negative 10, and I keep the variable. And then I have 2 times 4, which becomes positive 8. What I'm going to do now is just combine like terms. There's nothing that matches up with x cubed, but I notice there's like terms for the negative 5x squared and the 2x squared. So just for right now, I'm going to box those. I always want to include the sign. And then I want to combine, let's see, the positive 4x with the negative 10x. And it looks like I can't combine anything with the constant of 8. So all I'm going to do is just rewrite this. Let's do that in purple. I have x cubed. Then I go with my squares. Negative 5x squared plus 2x squared ends up being negative 3x squared, because negative 5 plus 2 is negative 3. Then let's combine our circles, which is positive 4x and negative 10x. Well, 4 minus 10 is just negative 6, and I bring my variable down, and then I'm left with my constant, which nothing combined with And that would be my solution after multiplying these polynomial expressions.